Finding the zeros. So far we've looked at problems like this, right? X squared plus 17x plus 70. They never equal anything. Well, it turns out that kind of the next step of this is just setting these problems that we've been looking at equal to 0. And there's a reason for this, right? These quadratics that we've been looking at, they all have the shape of a parabola. And we're going to learn, maybe even tomorrow, how to graph a parabola. But when we look at the shape of this parabola, one of the most interesting things about it, the mathematician, right, is not that it looks like a big smiley face, but where does it actually cross this x-axis? In other words, where is the y equal to what? 0. So when we set a parabola equal to 0, when we set a quadratic equation equal to 0, we are finding the zeros. We're finding the x-intercepts. They're also called the roots. So we're finding the roots. There's a lot of different terms for this. For now, we're just going to call it finding the zeros. But we're trying to find out where does this parabola cross the x-axis. And before we go on, I want to think about that. Does every parabola cross the x-axis in the same way? Could you imagine moving this parabola so that it would have a different number of x-intercepts? Like this parabola right here has 2 x-intercepts. Are there any other possibilities? Yeah. Okay. So if I move the bottom of it up where? So right here? Okay. And that very bottom of the parabola actually has a name. It's called the vertex. So if the vertex was right on the x-axis, how many x-intercepts would I have? 3. Wait, 1. Just 1. Yeah. Yeah, it's an odd number. Are there any other possibilities? Draw some other parabolas. How many intercepts does that one have? 2. 2. How about this one? Yeah.
1.
1. What were you going to say?
It like the finger like that.
Okay, if we change the shape,
then it wouldn't be a parabola.
Then it wouldn't be a parabola. But yeah, we could get different numbers of intercepts. And I like the way you're thinking, because if we think about right now, all you guys know how to graph really are lines, right? Lines pretty much always have 1 x-intercept. There's only one line, one type of line that doesn't, which is a horizontal line, right? And then parabolas, they could have 2 x-intercepts like this. They could have 1. And there's actually a third possibility. 0.
Oh, none.
Yeah, how could we have a parabola that has 0 x-intercepts?
It's above the...
Sure, if it were way above the axis, right? What do we call this bottom part of the parabola?
vertex.
If the vertex is above the x-axis and the parabola opens up. So it's possible when you see an equation like this, it's possible to get 1 solution, 2 solutions, and it's also possible to get 0 solutions. Okay? You don't necessarily know. Like, so far when we've solved for x, you could kind of look at the equation and say, oh, I know that there's going to be a solution for x. Or sometimes maybe there wasn't, right? But as soon as we introduce this quadratic, right, this x squared term, now there's different numbers of solutions that are possible. Okay? How do you think we're going to solve this? And what did we just spend like the past week and a half doing? Factoring. So If you had to take a wild guess at how we're going to solve this, what would you say?
Factor it.
Yeah. What would be our first step if we're factoring?
10, 7.
Yeah, so we'd say x plus 10, x plus 7 equals 0. How did that help?
It made it easier for us to count it.
No. We're actually not going to graph these to solve them. I was showing you like what they represent on the graph, but to solve these, we're actually going to do it algebraically, not graphically.
Now, if we were graphing it, you could plug in a number for x, like a solid number. So you could say like 2. So 2x plus 10 and then 2x plus 7. And then
you could kind of like find, if instead of 0, if we had y, you could kind of find
solution?
y. I like your thinking.
does that
So
not
what
make
we have
sense?
here is technically something. Let's just call this A. It's something, right? Times something else. Let's just call this B. A times B. A is x plus 10 and B is x plus 7. But we've got one thing times another thing equaling 0.
That means they both equal 0, or
Yeah.
one of them has to
Think
equal
about
0.
the rules for multiplication, right? If A times B equals 0, what do we know?
One of them is 0.
Yeah, one of them has to be 0.
So that means one of those x's x1 and then
Right, so what we can do is actually set up two separate equations. Either this has to equal 0, or what?
plus
X
7.
plus 7 equals that.
Exactly. Right? Wouldn't you agree? If two things are multiplying to equal 0, either this one has to equal 0 or this one has to equal 0. That's the only way that we ever get 0 when we multiply. Like 100 times 17 is never going to be 0. It's going to be some big number, right? Okay. And now you can solve this, right? X plus 10 equals 0. What's x?
Negative 10.
Yeah, x would be negative 10.
And since
Or-
they're both x, then wouldn't they?
Or x
Oh,
could be. Now, is it possible that we have two solutions?
Yeah.
Yeah, it's totally possible. Okay, it reminds you of absolute value where we had two solutions. Now, technically, with this, right, it's like x equals 10 or x equals 7. Like those are our two solutions to this. The absolute value is kind of like we usually would write. We write and? Maybe I don't remember. I think it's a little bit different from absolute value. I think. Maybe it's not. I'm trying to think. So what I'm thinking of in my head right now, this is an aside, but an absolute value graph looks like this. So actually maybe it is kind of the same thing, right? Because with an absolute value graph, you could have two roots, you could have one root. I never thought about that before. That's cool. So I guess in a way it's like the exact same thing as absolute value. In a way. That's cool. So the new step here is really this step here, right? And it turns out that there's a name for this in algebra. There's a name for that thing that I just kind of showed you, and you guys kind of figured it out intuitively. It's called the zero product property. And it says if A times B equals 0, then A equals 0 or B equals 0. This is called the zero product property. And this is what's called in math an inclusive OR. It's possible that they could both equal 0. Right? Because 0 times 0 is also 0. So when we say or, we really mean and or.
Yeah.
But we're just going to say or. So if A times B is 0, then A is 0, or B is 0, or they're both. And this is what lets us solve for the zeros. It's what lets us find the zeros, find the roots, that sort of thing. What other properties do you guys already know? Have you learned before? Distributive property, transitive property, commutative property. Okay, the identity property. How about the associative property? Do you guys know that? Yeah. So we're just adding another property to your list of properties that you know about algebra. And we use it to solve for x. Let's do another example. What if I had x squared plus 4 equals. Yeah. Okay. So how do I factor this side? X plus 4, x plus 1 equals 0. So what do we know?
X is equal to -4 and -1.
Okay. Yeah. I love that you made that jump. I'm going to write out the next step, which is that either x plus 4 equals 0 or x plus 1 equals 0. But a lot of times you guys probably will skip writing this step because you get really used to seeing this and just being like, oh, -4 and -1, right? Technically, we're skipping 2 steps because what I'm doing here is I'm subtracting 4 from both sides. And here I'm subtracting 1 from both sides. Right?
Is that all you're going to do? And then,
That's the solution to this problem. I'm finding what x equals. Yeah. Okay, what if I had something a little bit different? What if I had something like this? Okay, what is different about that?
Doesn't equal 0.
Doesn't equal 0. Can I solve it if it doesn't equal 0?
Yeah.
Let's think about it. If I factor this side and it equals -12, would there be anything I could do? Is there like a -12 product property? Probably not though, right? I mean, think about like how many different things could multiply out to be -12?
-3 and 4.
But also, couldn't it just be like negative 12 fifths
Wait, couldn't it
and
be
5? Yeah. Yeah. So you guys are all right. We can solve this, but we can't solve it while it doesn't equal 0. We really have to have it equaling 0 because there's only one 0 product property. There's not like a -12 product. There's not a 20 product property. Right? So I have to make it equal 0, but I can do that. I just simply add 12 to both sides. Right? And then what would I have? Over here, x squared plus 16x plus 15. And it equals 0. Because those are the like
yeah,
terms,
those are like
right?
terms.
I have to combine the 12 and the 3 because those are like terms. I can't combine 16x and 12. They're not like terms, right? Yeah, good question. All right, now what can I do? Factor it. How would I factor this? You think we can skip the zero product property step? Do you see the solutions? Yeah. Negative 15 or negative 1. Okay. What if I had something a little bit different? A little bit different still. What if I had something like this? Did I do that right? No, I did not. I think I did that. No, I definitely didn't do that right. Sorry. Minus 60. Alright, let's try this one. Oh yeah, equals 0, right? So if we're going to solve it, it has to equal something. Okay, what's the first thing you notice? Yeah.
Divide everything by 5?
Yeah, and I actually like what you just said, divide everything by
Everything, so you use 0?
5. Yeah, right? Now that we have equals, we could divide both sides by 5. So instead of factoring out the 5, I could divide this side by 5 and divide this side by 5. What's 0 divided by 5?
0.
0. And then this side, the 5s now are just going to cancel. Right? Oh, I did this wrong again.
Are you sure? It's x2 plus 2x minus 12.
I don't know why. I was trying to do this in my head. I'm pretty sure this is not going to work. Which I did not intend.
Mistakes made.
Because there's no factors of 12 with a difference of 2, right?
Well, they would have to. One would have to be negative though. One would have to be positive.
I kept multiplying 2 times 4 in my head, and I kept getting like the wrong thing. I don't know what I was doing. Doing 2 times 4 is 6.
Wait, huh?
2 times 4 is 12. No. So what I actually wanted was for this to be an 8. Anyway, so I can think of 0 factors of negative 12 that add up to 2. So what would we say?
Non-factorable or not.
Yeah, and actually in this case,
Not
now
wrong.
we would say
No
no
solution.
solution because
No
we
soul.
can't factor.
No soul.
So this is the problem that I wanted to do. Well, actually, I'll change it a little. Let's say we had 3x squared plus 6x minus 24. Okay.
Equals 0.
Equals 0.
You guys divide
Take out
3.
the 3.
Divide everything by 3. And remember, that since it equals 0, we can just get rid of the 3. When we were factoring, we had to keep it out front, right? But now, 0 divided by 3 is just 0. So what do we have?
X to the second plus 2x minus 8.
Equals? Yeah. 0 divided by 3 is 0. Okay. Factors of negative 8 that add up to 2. Those exist.
4 and 2.
4 and
Negative 2.
4 and negative 2. There we go. Okay. What would our solution be?
X equals negative 4, 2.
Yes. X would have to be negative 4 or positive 2. So this is just like one step further than factoring. And I thought it would be good to do it now because we're kind of reviewing factoring in a way. And then we're adding one more step. There are still problems that you guys don't know how to factor, right? But there aren't any of those on your own. So we do have one thing left to learn with factoring, but it's so connected into finding the zeros that I thought this was like a good next step. What are the types of problems you don't yet know how to factor?
When it equals 12.
No, so I'm talking about just this side, right?
Oh,
When can you not factor them? You guys don't really know how to.
when the A equals something.
Yeah, when A is bigger than 1 and you can't just divide it off. Like here it was bigger than 1, but we could divide it up. But if I gave you something like 6x squared plus 11x plus some other number,
Well, we do know how to do it if it's a
you can't
perfect
really
square,
factor that, right?
right? Because remember we do the thing where it's like 2x if it's 4.
Right, if you had a difference of squares, like 4x squared minus 36, you know how to factor that. I'm pretty sure there's none of those on your homework.
What if there are?
But I just wanted to kind of remind you that, yeah, there's not. I just wanted to remind you that we're technically kind of skipping ahead in a way. We know most of factoring, and we're looking at finding the zeros. We are going to add one more thing that will help you with factoring later. Okay, so the thing about quadratics is all this stuff is so connected, right? Like factoring, finding the zeros, making parabolas. There's not really like one order to teach it all in. Like I said, this week we're going to learn how to actually graph parabolas as well. And it's just like with lines. Like if you think about most of what we looked at last year, it was all about linear algebra. It was about lines, right? And we would solve systems of equations. Technically, a system of equations is what? You guys remember the solution? If I've got one line and then a second line, a system of equations, when I solve it, tells me that point where they intersect, right? So in a system of equations, I was trying to find the point where two lines intersect. You also were trying to like find x in a linear equation. So just like last year a lot of it was about linear equations, where we have x and y, but never x squared or y squared. A lot of what we do the first half of this year is going to be about quadratics. And it's really important, I think, to try to remember how all of these things are connected. So, right, just like a system of equations is the point where two lines intersects, finding the zeros is called finding the zeros because it's that place where the parabola crosses the x-axis. And even though we never, after I showed you that at the beginning, we never looked at a parabola today. You don't have to graph these to find that point. There's still those two different representations of what we're doing. And it's important to keep those in mind, right? What does it mean when we get no solution? It just means that that parabola is either above or below the x-axis and pointing away. So it never crosses. But that equation could still be represented by a parabola, right? So there's lots of different ways of representing these. And they all go together.
The end.